We're going to figure out the derivative of arcsine or inverse sine of x using implicit differentiation. So first we want to start by making this an equation, y equals sine inverse of x. And we might want to remember what values sine inverse of x can take and what values you can put in for x. So if you're going to ask the question, sine of what number gives you x, x is going to have to be between -1 and 1. And to have a function for inverse sine, we're going to have y be between -pi/2 and pi/2. Alright, so now if we want to take this derivative, we don't know how to take the derivative of arcsine, but we do know that if we take sine of both sides, sine of inverse sine undoes each other as long as we're on this restricted domain over here. So we can say that sine of y is equal to x. Now we're ready to take d dx of both sides. Well, d dx of sine of y, the derivative of sine of y is cosine of y. And then we have to multiply using the chain rule by dy dx. And the derivative of x in terms of x is just 1. So solving for dy dx, we get that dy dx is equal 1 over cosine of y. Now that sounds fine and dandy, but the problem is we want our answer in terms of x, because our original problem was in terms of x, not in terms of y. So how do we go back from cosine of y, how do we get to x's? Well, the only thing we know about x is that sine of y is equal to x. So we need to rewrite this expression in terms of sines instead of cosines. So we're going to use the fact that cosine squared of y plus sine squared of y is equal to 1. We're going to solve for cosine of y. So cosine squared of y equals 1 minus sine squared of y. And so cosine of y is equal to the square root of 1 minus sine squared of y. And now we can substitute in for cosine of y square root of 1 minus sine squared of y. So dy dx equals 1 over the square root of 1 minus sine squared of y. And that helps us because now we can replace sine of y with x. So we get dy dx is equal to 1 over the square root of 1 minus x squared. So now we have a formula for the derivative of arcsine.